Good afternoon, friends. Myself, Professor M.A. Chennaiya. In this video, we have given a problem on in the form of a statement. This figure is not given to you. The question reads like this: a hemisphere of diameter 50 mm, diameter is 50, rests on its flat surface on the center of flat surface of another sphere, another hemisphere. Another hemisphere. There are two spheres, both are hemispheres. So, friends, we have got a bigger hemisphere which is having radius equal to 50 millimeter, and the other one is a smaller hemisphere which has got a diameter equal to 50, such that the center of this and the center of this, they lie at the same height. So, friends, we are required to draw the isometric projection of the combination of these two. So, to tell you, there is a big hemisphere on which another small hemisphere is resting like this, and we need to draw the combination, the isometric projection of the combination of solids. Friends, you know the center of this is here, center of the top one, and here, as per the problem, we have got the maximum dimension of 50 millimeter, and this 50 millimeter taken in the isometric scale, that is 50 into 0.815 is the side of this. And friends, this height whatever you have got here is 50 times the radius, 50 r. R is equal to 50. So this height is going to be 50, but in iso, because you know very well, for all the isometric projections of sphere or hemisphere, the height whatever you take should be the iso height. And while drawing the circle, this head for both of these, we are going to make use of the actual scale, not isometric. So friends, here, see, I am enclosing this hemisphere, bigger hemisphere in a box, and this box will have obviously 50 radius, means the height you should take in 50. So I'll write down here ISO 50, isometric height 50, here also isometric height 50, this side also same thing we take, and these two lines are at an angle of 30 degrees to the horizontal. Friends, I have located the center of this. That center is here, friends. And the height, whatever I have taken, is shown here. Friends, the sphere or hemisphere or a circle, they appear as ellipses in isometric projection or isometric drawing. So, friends, we have to get one ellipse for the smaller hemisphere and one bigger ellipse for the bigger hemisphere. So friends, what we do, I have constructed a box here having ISO 50, this height ISO 50, and height is also same ISO 50. And here friend, this diameter is, height is ISO, that is, it has to be this side. The side is not 50, it's going to be 100, ISO 100, sorry, because the diameter is 100 and this height is equal to the ISO height, ISO radius, ISO value. Now friends, at the top of this, we are going to construct two ellipses, one for this 100 millimeter dia. And here friends, what I do, I make use of the simplest method, that's called force center method, to obtain an ellipse in this parallelogram. So friends, here first of all let me construct the bigger ellipse at this ISO height of 50. This ISO 50 is the height and this is 100. Okay. Now friends, what to do to get this? I take this as the center, say some center of this, and I join this to the opposite side center. See, I have taken one of these corners. join that to the opposite side center somewhere here. So it is intersecting this diagonal line here at this point. So taking this as center and radius equal to this much, I am going to draw an arc, a simple arc here. Similarly, friends, here on the equal side, equal distance, which can be obtained again by joining this corner to the opposite side center. We are getting center C2. With center C2 and the same radius, whatever you have taken here, I am going to draw one more arc of a circle. Friends, this is the center 3. We call it as C3. With this as center and this distance as radius, I am going to draw the third arc using center C3. Friends, this becomes a C4 with this radius. Center C4 and radius equal to this much. I am going to complete this ellipse part. Friend, this is the ellipse drawn for the top surface which has got a diameter of 100, that you can see 100 millimeter. Now friends, on the same lines we have to draw one more ellipse for this part of the smaller hemisphere which is having diameter 50 and height is equal to how much? Height is equal to 25 only. So now friends, what I do, I follow the same procedure, obtain for the smaller parallelogram here, the using the 4 center method, what we call, we are going to have another smaller ellipse. How to obtain, friend? So I will take this as the center, opposite center as the distance, take the center C1, opposite side as the radius. You can just obtain this point center 1 for that. With center 1 and this as the distance, we can construct an ellipse here. Similarly, by joining this to the opposite side, you are going to get one more point here, and taking this as center with the same radius, whatever you got here, draw another semicircle or an arc of a circle to say. And friends, finally we have center C3 and this as the radius, we can have one more ellipse, and finally with this as center you construct another ellipse or an arc of a circle. Friends, here we have used these centers and obtained two ellipses, one for the smaller hemisphere, this is for the bigger hemisphere having a diameter is equal to 100. So friends, now with this we have got the isometric projection of this hemisphere, isometric projection of this hemisphere, which is the larger of the two. Now friends, in all the isometric projections, we make use of the actual radius of the sphere or hemisphere to draw a circle. So friends, what I do, taking this as the center and radius equal to, this is 50 dia, radius equal to 25, I am going to draw an arc. This center, an arc I am going to draw. Probably friends, you are going to get like that. Similarly friends, for the bigger hemisphere which is having 50 millimeter radius or diameter 100, this is 50 radius, this have taken 50 iso, so take the same center and radius equal to actual 50 mm. I am going to draw one more circle which is tangential to this. So friends, if you take that as a center, probably you are going to get an arc like this. And this is how we draw this. And friends, it should be tangential. No, it will not go there. This is for the bigger one. Yeah, this is perfectly right. And this again somewhere here. This is the hemisphere we see in isometric. Friends, now we have got the isometric projection of both bigger hemisphere and the smaller hemisphere. And friends, now we will remove all these unwanted lines so that you will get a clear picture of this isometric projection. So let me remove all these construction lines used to obtain that figure. And here, friends, this is the larger hemisphere, and this is going to be just tangential to that. Now this is for the other one. So these two are going to be concentric ellipses. So this rear portion is not visible to the observer, and generally no hidden lines or dimensions are shown. So we will remove this also, and friends, you will have a clear picture of a smaller hemisphere sitting on the top surface of a bigger hemisphere, and this is how we obtain the isometric projection of the combination of solid when the question is given in the form of a statement. Here the question is given in the form of a statement. So friends, I hope you have liked the video, and please go through the complete video. And if you like this, do share this information about my video with all your friends. Have a blessed day. Thank you very much for watching my YouTube video.